Hello, this is Nicole Hemsoth, editor of HPC Wire, here with another in our series of in-depth interviews. Today we'll be talking with Peter Pila, the VP of Engineering at TerraScala, about efforts underway to make HPC more efficient. Hi, Peter. Thanks for taking time today.
Hi. Pleased to meet you, Nicole.
Do you mind giving us a little background on your work in high-performance computing?
Yes. I mean, you mean TerraScala in general, or me personally?
Let's start with you and how you came to the position where you're at. I know you're VP of Engineering, and you also manage one of the core components of the TerraScala business. You can get to that at the end if you'd like.
Yes. No, I've been in HPC proper for about 3 years now, and that's been my tenure at TerraScala. And as you mentioned, I manage the development of the TerraOS software product that basically powers our high-performance storage appliances. I'm actually a chemical engineer by education, and my specialization was in computer-aided process design and process simulation. So I really have a pretty deep background in detailed numerical analysis and simulation. So I've really been able to bring quite a bit of that knowledge into my work here at TerraScala.
Okay, great. Exactly how does that fit into TerraOS? I don't know that we've covered it in depth. If you want to describe it very briefly before we get into the topic of today's interview, that'd be great.
Yeah, I mean, basically, TerraOS is a unified software distribution. It contains a Linux kernel, a Linux user space, the Lustre file system, and then a number of tiers of management software that TerraScala provides. So basically, that distribution can be installed on certified hardware components, storage arrays, servers, and basically build very rapidly a high-performance storage appliance based on the Lustre file system. And again, the appliances we build are intended mostly for the commercial market, and we place a very high importance on reliability, availability, serviceability, and manageability features.
Mm-hmm. That's a pretty crowded marketplace there that you just described as far as where you fit into it. Where's the differentiating factor in what you do versus what the rest of that, again, very competitive market does?
Yeah, I think, we like to think that we're really the only vendor that provides a true appliance to our customers. So basically, when a customer receives a product from TerraScala, it's a fully manufactured hardware, software combination. It's ready to start work on day one. Also, other areas of differentiation. Again, management has been something that we have recognized the importance of from day one. Our first generation management, really looked at the appliance primarily as a set of hardware components, and the goal was to be able to detect component failures and alert the user to that, and then initiate some kind of remediation. In Generation 2, we recognize that basically there's a file system running on top of those hardware components, and for people to get value out of their storage, they really need to understand how their applications are interacting with the file system. And then I think in Generation 3 that we're heading towards, there'll be a much greater emphasis on actually the performance of the applications and the workflows that surround them.
Mm-hmm. That's kind of interesting then. As a former scientist, you can bring a lot of experiences to bear about, why are these challenges so persistent? What do actual practitioners need on the modeling and simulation analysis side? On that note, by the way, I know that TerraScala had an announcement today where they were discussing sort of an overarching theory of providing efficient HPC for organizations that are again, very dependent on simulation, modeling, analysis for their competitive edge.
Yeah.
So you said something today about a holistic HPC approach that's targeting application and workflow productivity, and then also looking at individual component performance. It's very broad. Can you help us boil this down and put it into some kind of practical context?
Yeah, I think the thing is, we see three, I would say, overarching, trends in developing in HPC, especially as it applies to commercial customers. One is that, HPC, once upon a time, was really the domain of the national lab or the high-end educational institution. More and more, with the explosion of big data, commercial enterprises are needing to take advantage of HPC technology in order to do their work better. The second thing that we see is that, in order for customers to really realize the value from their HPC infrastructure, they really need to understand how it's performing in the context of their actual applications. So again, storage analytics has been something that we've been working on for a couple of years to try and give customers the kind of data they need to make intelligent workflow decisions, application tuning decisions, etc. And then the last challenge that we're focusing on is data movement. So, basically HPC storage is essentially scratch-based. And in order to get value from it, you have to be able to transfer assets from long-term project-level storage into Scratch, compute on it, and take results data sets and return those to enterprise storage. Now, today, you hear a lot of talk about HSM, which primarily seems to be a problem around administrators really having to deal with purge cycles as their scratch storage becomes increasingly utilized. We take a different view of it. We really see that instead of making this an IT issue, data movement really belongs to the core workflow and the application user. And really what's needed is for users to have access to tools to help them perform the data movement tasks in an efficient manner as part of their HPC workflows. Okay,
excellent. I think the building is coming down around you there, Peter. I hear a lot of construction.
I'm sorry about that.
It's fine. It's fine. It's nice background noise. So to get over to something that your CEO said when he was talking about this holistic data approach, I think this is an interesting broader topic that we might want to drill down on. You come out of academia, research science, and using these systems, and you're pushing this product toward commercial plus HPC users. Where are the differences and the gaps and needs between, say, a commercial big data shop and data-intensive analysis at a national lab, say, for instance? And how can you possibly fill all of those gaps at once? It seems like there's a wide variance of needs there.
All right. I think there's definitely a wide variance of needs. I think in the commercial enterprises, we're seeing there's actually a couple of audiences. There's an IT audience, and then there's a user scientist audience. For IT, what we're finding is that really the thing that they're looking for most is for their HPC storage appliance to really resemble in terms of, again, reliability, availability, serviceability, the kind of features that they get from their scale-out NAS enterprise storage that they're most familiar with today.
Okay.
The challenge is really to make HPC as easy to use, deploy, and manage as technologies that they're already comfortable with.
Okay.
In terms of working with HPC or application users, they're really looking for the kinds of information about their infrastructure that will help them make workflow decisions that can basically improve their overall productivity. That's what we're seeing. So, whether it be, gene sequencing workflows or, seismic analysis for oil and gas, users have these applications. They're trying to do more work with them, and they really want to understand what, if anything, they can do in their workflows or application configurations to get greater productivity from their HPC infrastructure.
Okay, great. Just a side question. I'm not sure if this is really information you have on hand, but where's the hot growth area that you're seeing right now, whether it's HPC specific or on the enterprise side or some point in between?
Well, we're seeing a lot of activity in the life sciences area around HPC. And again, I think manufacturing is another pretty hot area, vertical, and again, traditional areas like oil and gas, seismic exploration are strong also.
Mm-hmm. When you say manufacturing, can you give me a better idea of what that means? It's very broad, and you get occasional use cases of manufacturing users. It's usually CFD type applications. What does it look like from your end?
Right. So yes, we see a lot of activity, folks doing CFD or doing stress analysis as part of bringing new products to market. Looking at different alternate designs, trying to do things like material optimization. Minimize the amount of material while maintaining the integrity of the product. And as you say, CFD around fluid flow, energy distribution. Those are the typical applications that we run into in the manufacturing sector. Also there's some specialized areas. People doing things like automotive engine simulation, for instance, is something that we've come across, quite a bit.
Mm-hmm. Okay. Such a fascinating ecosystem. We'll be following your role in it as you guys continue to grow throughout the year. And Peter, thanks a lot for taking time today.
Oh, you're most welcome. And, look forward to speaking with you again.